Hey guys, it's Ms. Seifert here. Just wanted to go over a few things related to the atmosphere and weather. These are really important concepts that'll be on the SOL, and wanted to kind of help you guys work through the section in your packet. First and foremost, our atmosphere developed very early. It was primarily carbon dioxide, and one of the first life forms on this planet was cyanobacteria, which produces oxygen as a byproduct. They engage in photosynthesis. So that release of oxygen and water by cyanobacteria helped to develop our early atmosphere. The atmosphere is about 21% oxygen and 78% nitrogen. There are a couple other things mixed in, but those are the primary ones, okay? Other planets, Mercury doesn't have an atmosphere. Venus has carbon dioxide. It is a runaway greenhouse in terms of any sunlight coming into its atmosphere really gets trapped there, and it really magnifies the temperatures on Venus. Mars has a little bit of carbon dioxide, but not much at all. And what we've discovered only during the course of this school year is that Mars actually lost its atmosphere. At one point it had one, but it appears to have been lost due to magnetic storms by the sun. But basically, the atmosphere works to balance the radiation that comes in and leaves our planet, and helps to provide for life on our planet. So the layers of the atmosphere are based on temperature, going from the surface out. The troposphere, this is where weather happens. We live here. This one's really important to us. Above that is the stratosphere. And the stratosphere includes the ozone layer, which filters out a lot of harmful ultraviolet radiation from the sun. In fact, we didn't realize just how much UV radiation was filtered by the ozone layer until we started sending people into space and they were exposed to much higher levels of radiation than we are down here on the troposphere. The mesosphere is the third layer out. This one we taught you in 6th grade, that the mesosphere is where meteors burn up. It does in fact also protect us from space trash. We've left some things out in space over time, and most of the time they burn up in the mesosphere. So a lot of our meteor showers, what you're seeing is pieces of rock that are breaking apart in the mesosphere. The thermosphere is very, very hot, and this is where you're also going to find the ionosphere, and the exosphere refers to outer space. Okay, so global wind patterns. This is really important because as sunlight comes into our atmosphere, it is moved, that heat is moved around the Earth. Okay, so it does so through kind of these specific patterns for the most part, and that has to do with the Coriolis effect. They curve based on the movement of the Earth, the rotation of the Earth. So first you're going to have the northeast trade winds. Okay, and you can see that these move opposite directions depending on whether you are north or south of the equator. So you have the northeast trade winds, which are coming from the northeast down, or you have the southeast trade winds, which are coming from the southeast towards the equator. Okay, you've got southwesterly winds, and you've got polar easterlies. Now, our prevailing westerlies are the systems that carry most weather patterns across the United States. And so that's why most of our snowstorms hit West Virginia and then come down towards us. Same thing with the derecho that happened. It kind of came out from the west and hit us. When you see clouds coming from the east, it's typically because we're about to have a hurricane or tropical depression. Jet streams are very high altitude winds, and when planes fly in them, it actually reduces the amount of fuel that they need to use to power themselves. So these global wind patterns are really important. Obviously, sailors would have known about them and used them quite often in order to navigate the seas. Types of heat transfer, you've done this before, guys. Radiation is heat transferring through space. So the sun, that's radiation. If you're a few feet away from a fire, but you can feel that heat, that's radiation, okay? Conduction is heat transfer through touch. So when your pan is on the stove and it's touching the heat element and it's getting hot that way, that's conduction. If you put your hand on a hot stove and you burn yourself, that's conduction. Convection is movement of heat through a fluid. So it's that circulation, and we see this in clouds, okay, where you've got, air gets heated by the surface, it rises, it cools, and it sinks again. We see that same type of convection transfer in the mantle, where you've got warm rock, gets heated by the core, rises up towards the crust, releases a lot of that heat energy, and then as it does, it becomes more dense and it sinks back down towards the core where it's heated again. We see the same convection currents in a rolling pot of water when you've got it boiling, and you also see it in the oceans, that you've got you've got movement in a circular pattern, okay? Local wind patterns, okay? Land heats and cools quickly. It's much more fast than water. So this is why when you run out to the car barefoot at 11 a.m. during the summer, you may actually hurt your feet running across the concrete. Meanwhile, if you go jump in a pool first thing in the morning, it's very, very cool, even if the air has already warmed up. So because land warms up faster than the water, you're going to get these wind patterns. So during the day, you've got warm air off the land that rises, okay, and the cooler air from over the ocean blows in. This is called a sea breeze. It's named for where it's coming from. At night, on the other hand, you've got warm air over the water that rises, and so you've got the wind is coming from the land. This is a land breeze, okay? Solar radiation, the angle of incidence, this is what explains our seasons, okay? When the North Pole is tilted toward the sun, we're having summer. When the North Pole is tilted away from the sun, we're having winter, okay? So this is the December solstice and the June solstice. At times where the Earth, the axis, neither pole is pointed toward the sun, that's when we have the equinox, either the spring equinox or the fall equinox. Those are called vernal for spring or autumnal for fall. Pressure systems. Isobars on the map indicate areas of equal pressure. Isotherms on a map indicate equal temperature. So when you're looking at pressure, that's measured by a barometer, typically in millibars, and you're looking at like 1,000 to 1,100. That's going to be your range of pressure, okay? Obviously, isotherms, when you're looking at temperature, you should see something that resembles temperature. So anywhere from, 0 to 100 when we're looking at Fahrenheit, anywhere from, -5 to, say, 25 or 30, we're looking at Celsius. You're not going to see much above that, okay? High pressure gives us good weather. It prevents water from evaporating. It prevents storm systems from forming, and so we end up with really clear skies. In a low pressure system, you do have the potential for clouds to form and for storms to happen. So the example I give is when we had that polar vortex that closed school for like a week a couple years ago. It was beautiful outside, not a cloud in the sky, but that was a polar high pressure system. And so even though it looked really nice out, it was freezing. Okay. Types of lifting, you've got convergent, you've got convection, you've got orographic. May not see this so much on the SOL, except that as the clouds get lifted over the mountains, they end up dropping a lot of their moisture, because as they get lifted, that moisture cools, and so you get a lot of rain on that side of the mountain. Okay, types of precipitation, you know these, you've studied them forever. Okay, types of fronts, these are really important. Air masses are based on temperature and moisture. So maritime is wet, tropical is hot, continental is dry, and polar is cold. Front is the boundary between air masses. You've got a cold one. This has blue triangles. We refer to these as the blue icicles. Okay. A warm front, on the other hand, is going to have red semicircles, which look like suns. It is warmer. Okay. They always point in the direction that they're heading. So this blue one is going downwards. This warm front is going upwards. All right. In a stationary front, what has happened is a warm front and a cold front have collided, and neither one of them is really strong. So they're just going to kind of be stuck there. You're going to get several days of rain. Okay. And this is an occluded front, where you've had a warm front or a cold front overtake the other one. And so it's actually lifted the warmer air completely off the ground. Okay. Key terms, again, polar is cold. It originates near the poles. Tropical is warm. It's coming to us from the tropics. Maritime is coming from the ocean, so it's very humid. And continental is coming from land, so it's going to be very dry. Okay. That's going to be it for this one. And I will continue working on your next one. Thanks.